Hey guys, it's me, Colin Yin. So today what I would like to talk about is what is laminar flow and what is turbulent flow. I'm sure many of you are familiar with the word turbulence since it comes up very often when you're flying on an airplane. Your pilot would always say something like, attention all passengers, please buckle up your seatbelts as you'll be experiencing some turbulence. Then the plane starts shaking like crazy. Have you ever thought what exactly is going on and why this is happening? So to understand this phenomena, let us get back to understanding what is laminar flow and what is turbulent flow. Laminar flow is when the fluid flows with no significant mixing of neighboring fluid particles, whereas turbulent flow is when the fluid motions vary irregularly so that quantities such as velocity and pressure show a random variation with time and space coordinates. If we look at a fluid flowing through a pipe, we see that the laminar flow is very orderly. The streamlines are very straight and parallel to one another, so no mixing occurs between them, whereas we see the turbulent flow being very chaotic and the streamlines are essentially all over the place. Now, I'm sure that many of you are just like, huh? What did he say? Streamlines and mixing and fluid particles? I understand there's some confusion, but don't worry. To understand this better, let us look at a very famous engineering term called the Reynolds number. The Reynolds number is the inertial forces over the viscous forces, which equals the velocity times length divided by kinematic viscosity. From this, we see that the Reynolds number is dependent on the geometry of the pipe, the velocity of the fluid, and the viscosity of the fluid, where the viscosity referring to the stickiness of the fluid, such as honey being stickier than water. So what we know now is that the inertial forces refer to the geometry and velocity of the pipe and fluid, whereas the viscous forces refer to the stickiness that we mentioned earlier. We see that with a high Reynolds number, the flow is turbulent because the inertial forces are larger, making the Reynolds number larger. With a low Reynolds number, the flow is laminar because the viscous forces are larger, making Reynolds number smaller. Here is a simple experiment to help us better understand the laminar and turbulent flows. This here is a laminar flow. Watch closely as I slowly open the tap. This here is a turbulent flow. Then watch closely as I slowly close the tap. I've brought it back to laminar flow again. By increasing or decreasing the flow disturbance, I'm able to change the flow from laminar to turbulent or from turbulent to laminar. I hope this was able to help you understand what laminar and turbulent flow is. Please like and subscribe if you enjoyed the video.